Exercise 6.6 optional chapter 6 triangles. We'll start with the first question. We'll go into in the figure PS is the bisector of angle QPR of triangle PQR. Prove that QS by SR is equal to PQ by PR. So now solution for this problem is we have to do some construction part. What is given, what is required to prove, we'll see. In the given figure, PS is the bisector of angle QPR, you can see, of triangle PQR. To prove that QS by SR is equal to PQ by PR. Now what is the construction we are going to do? Just look into the next figure which we have here. Construction, we are drawing RT parallel to SP to meet QP produced in T. So this line QP is produced to T. You can see here it is produced to T. Now draw RT parallel to SP. We are drawing RT parallel to SP to meet QP produced to T. So since RT is parallel to SP and transversal PR intersects them, you are having angle 1 and angle 2 are alternate interior angles. You can see obviously from here this angle and this angle are two alternate interior angles. Then you are having RT, since RT is parallel to SP and transversal QT intersects them. Since you are having these two lines, this is RT and this is SP and this is QT which intersects these two. These two angles are nothing but these two are said to be, this is 4, this is 3. These two are said to be corresponding angles because this is the transversal for these two parallel lines. Therefore here these two are corresponding. Angle 3 is equal to angle 4 because they are corresponding angles. Now but we have angle 1 is equal to angle 3 because this is PS is the angular bisector of QPR. So therefore we have angle 2 is equal to angle 4 from 1 and 2. We can see this obviously because angle 1 is equal to angle 3, therefore angle 2 will be equal to angle 4 from 1 and 2. So therefore, if angle 2 and angle 4 are equal, we can tell that angles sides opposite to equal angles are equal. Therefore PR is equal to PT. That only we have written here. This is the third equation. Since sides opposite to equal angles of a triangle are equal. Now in triangle QRT, so we are taking QRT, the bigger triangle with this dotted lines from here, this Q, R and T. So in this you can see that PS is equal to RT. PS is equal to RT. It's there given to us. Then we have also have that by construction, and therefore QS by SR is equal to PQ by PT by basic proportionality theorem, which implies that QS by SR is equal to PQ by PR from the third part. PT is equal to PR. So in the place of PT we are writing it as PR from these two. So therefore we can tell that this is what we had to prove. Hence proved QS by SR is equal to PQ by PR. Next, second problem. From figure, D is a point on the hypotenuse. You can see here clearly that D is a point on the hypotenuse AC of triangle ABC. DM is perpendicular to BC and DN is perpendicular to AB. Prove that DM square is equal to DN into MC. And second one, DN square is equal to DM into AN. So here we have two things to prove here. So we have AB is perpendicular to BC is given to us and DM is perpendicular to BC. So which implies that AB is parallel to DM and also DN is parallel to BC. Similarly we have CB is perpendicular to AB and DN is perpendicular to AB, which implies CB is parallel to D. Quadrilateral BMDN is a rectangle. Therefore BM is equal to ND. So still here we got BM is equal to ND. So in triangle BMD, you can see again I have drawn the figure here. In triangle BMD, which I have shaded over here, this part, this triangle BMD, we have angle 1 plus angle BMD plus angle 2. Here you are having angle 2 and here you are having angle 1. So these three angles if you add, it's equal to 180 degrees, and you know that angle BMD is nothing but 90 degrees. Therefore angle 1 plus angle 2 is equal to 180 minus 90, which is equal to 90. So 1 and angle 1 plus angle 2 is equal to 90. Similarly, if we consider triangle DMC, the other triangle, the other side, so angle 3 plus angle 4 is also equal to 90 degrees. Since BD is perpendicular to AC, we have that BD is perpendicular to AC, angle 2 plus angle 3 is equal to 90 degrees. So now angle 1 plus angle 2 is equal to 90 degrees, and angle 2 plus angle 3 is equal to 90 degrees. We can see obviously from this figure. Therefore, which implies that angle 1 plus angle 2 is equal to, because both are 90, we are equating both of them. Therefore, angle 1 plus angle 2 is equal to angle 2 plus angle 3. Angle 2 will get cancelled. Therefore, we are having angle 1 is equal to angle 3. Now we have angle 1 is equal to angle 3. Also similarly, we can show that angle 3 plus angle 4 is equal to 90, and angle 2 plus angle 3 is equal to 90 degrees. Therefore, if you equate both of them, because the right hand side is 90, you are getting angle 3 is cancelled over here. So therefore angle 2 is equal to angle 4. Thus in triangles BMD and DMC, we will again draw the figure over here so that it will be a clear picture for you. So this is ABC. This point is D, and this is N. It's perpendicular to AB. DN is perpendicular to AB, and DM is perpendicular to BC. So now in triangles, here you can see BMD in these two triangles. This is one triangle and this is the other triangle. In these two triangles, in triangle DMC and BMD, we have that angle 1 is over here. This is angle 1. This is 2. 3 is up here. 3 is here, and this is 4. So these angles we are having. So angle 1 is equal to angle 2. Angle 2 is equal to angle 4. Therefore, by using WA similar condition, we have triangle BMD is similar to triangle DMC. Since if two angles of two triangles are equal, then we can say those two triangles are similar. So using similarity criterion, therefore which implies that now we have, since two triangles are similar, we can say the sides are proportional. Therefore, what are the two sides which we are considering? We are considering in order. Just look at this triangle. We are taking BM by DM, the first two sides over here, BM by DM proportion we are taking for this, then is equal to MD by MC. Now we have that MD can be written as DM, and BM is equal to DN. We have proved previously here. BM is equal to DN here. You are having from this, since it's a quadrilateral rectangle, the quadrilateral BMDN is a rectangle. We have that BM is equal to DN. From here also you can see from this figure, BM is equal to DN. Opposite sides are equal, which is equal to MD by MC, or you can write MD as DM by MC. Therefore, if you cross multiply this, you will get it as DM square is equal to DN into MC. Hence the first part is proved. Now next, second one, proceeding as in one, we can prove that triangle BND. Here you can see that BND is this triangle and AND is this triangle. So in these two triangles, what do we have? Or DNA, you can take anything. So here we are considering these two triangles. When we are considering, we are taking these two first two sides over here, BN, and here DN. These two sides are proportional. Therefore, BN by DN is equal to ND by NA, which implies that DM by DN is equal to DN by AN. ND can be written as DN. So DN by and NA can be written as DN. Therefore, since we have BN is equal to DM, now we have DM by DN is equal to DN by AN. Now cross multiply, you will get DN square is equal to AM into AN into DM. Hence proved. Now look into the third one. In the figure below, triangle ABC is a triangle in which angle ABC is equal to is greater than 90 degrees and AD is perpendicular to BC produced to D. Okay. Prove that AC square is equal to AB square plus 2BC into BD. We have to prove this. This is A plus B whole square formula. That is AB plus BC whole square formula we have to get out there. So how do we do this? We'll just see. So now given an obtuse triangle ABC, an obtuse angle at B, because this angle is greater than 90 degrees. It is greater than 90 degrees this angle, and AD is perpendicular to BC produced. When BC is produced to D, then you can tell that AD is perpendicular to CD or BC. To prove that AC square is equal to AB square plus BC square plus 2 into BC into BD. Now in right triangle ADB, we have that AB square is equal to AD square plus BD square, because from Pythagoras theorem it's a right angle triangle, therefore the hypotenuse square is equal to sum of squares of the other two sides. So we have written that. Now in triangle ADC, the bigger one, because this is also a right angle triangle, you can write this as AC square is equal to AD square plus CD square. Now what is CD square equal to? CD can be written as BD square plus BC or DB plus BC whole square. So now we are going to expand this. So AC square is equal to AD square plus DB square plus BC square plus 2DB into BC. We are using a plus B whole square formula, which is equal to A square plus B square plus 2AB. So we have written that here. So in that form, therefore, which implies that AC square is equal to AD square plus BD square. You can see over here AD square plus BD square, from 1 you can see very clearly that it is equal to AB square plus BC square plus 2BC into BD. So we can see this, hence proved. This is what we had to prove. Next, fourth one. In the figure, ABC is a triangle in which fourth one, in the figure ABC is a triangle in which angle ABC is less than 90 degrees. Like the previous problem, that was an obtuse angle, this is an acute angle, and AD is perpendicular to BC. Prove that AC square is equal to AB square plus BC square, which is minus 2BC into BD. So we have to prove this. It is previously plus over here, now we have to prove that it is minus here. So an acute angle triangle, consider this acute angle triangle, acute angle at B, and AD is perpendicular to BC. To prove that AC square is equal to AB square plus BC square minus 2BC into BD. Now in triangle ABD, we have that, you can see since AD is perpendicular to BC, here you are having in triangle ABD, AB is the hypotenuse, therefore it is equal to square of the other two sides. Sum of the hypotenuse square is equal to, hypotenuse square is equal to sum of the squares of the other two sides. Therefore AB square is equal to AD square plus BD square. Just take it as equation 1 using Pythagoras theorem. Next, consider the other triangle, that is ADC. First we considered this triangle, now we are going to consider this triangle. In this triangle ADC, you have AC as the hypotenuse, so AC square is equal to AD square plus CD square or DC square. Now you know that DC here can be written as BC minus of BD, BC minus this whole part from here to here minus of the small part will give you this part. This part it will give you. So therefore you are having CD square is equal to BC square minus BD, or CD is equal to BC minus of BD. So now we are taking whole square over here. So you are getting AC square is equal to AD square plus BC square minus 2BC into BD plus BD square. So which implies that AC square is equal to AD square plus BD square. You are taking this BD square together here, and you have proved from this part here already that AB square is equal to AD square plus BD square. So now you have written here AB square plus BC square minus 2BC into BD, hence proved. Now going into the fifth problem. In the figure, AD is the median, is a median of triangle ABC, and AM is perpendicular to BC. AD is the median, means it's dividing the base into two equal halves. AM is perpendicular to BC means it's making an angle of 90 degrees where it's meeting this BC. So therefore AC square, we have to prove that AC square is equal to AD square plus BC into DM plus BC by 2 whole square. Next, second part, AB square is equal to AD square minus BC into DM plus BC by 2 whole square. Third part, AC square plus BC square, both of them you are adding. So what do you get? 2AD square plus half BC square, because these two will get cancelled over here. So now we'll look into the figure here. In this figure, what do we have here? In right angle triangle ACM, AMC is a right angle triangle we have here, isn't it? So we have AC square is equal to AM square plus MC square. You can see very obviously from this triangle here, which I am drawing here now. This part, this triangle which is considered in yellow now, we have considered this triangle. So in this triangle you can see that AM square, AC square is equal to AM square plus MC square. So using Pythagoras theorem, now AM square plus MC square can be written as MD plus CD. You can see very obviously from the down part of there. So now you can see that AM square plus MD plus CD whole square, which can be written as MD square plus DC square plus 2MD into DC, when MD plus DC whole square is expanded. Since we know that AD square is equal to AM square plus MD square, this two together we can write it as AD square, because we know from the previous year, you can see from the top of there, you have from directly you can write down AD square is nothing but equal to AM square plus MD square. So therefore plus, what is DC equal to? DC is equal to, because D is the median of the base, so you can tell that half BC. It is AD is the median of the base BC, so it divides this into two equal halves, that is BD is equal to CD. So therefore CD can be written as half of BC plus 2 into DM, MD can be written as DM into DC is again written as half BC. So 2 will get cancelled. So what are we left over here? AC square is equal to AD square plus 1 by 4 BC square plus BC into DM is the first part which we had to prove. So now again considering this second part, in right triangle ABM, you can see the figure over here. We have that AB square is equal to, it's a hypotenuse, is equal to AM square plus BM square using Pythagoras theorem. Now what is BM written as? BD minus of MD. So in the place of BM we are writing it as BD minus MD whole square. So AM square plus BD minus MD whole square is equal to AM square. Now we are expanding this part. So A minus B whole square formula, BD square plus MD square minus 2MD into BD, which is equal to, now you are having that AM square plus MD square is nothing but equal to AD square. You can see this is a right angle triangle. Since this part is a right angle triangle, you have that AD square is equal to AM square plus MD square. So plus BD square. Here from this figure we have that plus BD square minus 2BD into MD. So which is equal to, you are writing in the place of this AD square plus, what is BD equal to? Because AD is the median, you have BD is equal to BC, so it can be written as half BC whole square minus 2 into half BC into DM. So now this will be written as AB square is equal to AD square plus 1 by 4 BC square minus BC into DM. This is the proof for the second part. Now what we are doing, the first and the second part, this is the proof for the third one. So adding 1 and 2 we get AC square plus AB square is equal to 2AD square plus half BC square. You get this part cancelled over there, BC into DM. So when you add both 1 by 4 BC square plus 1 by 4 BC square, you are getting 2 by 4 BC square, which is nothing but 1 by 2 BC square. Hence proved. Now going into the sixth one, prove that the sum of squares of the diagonals of a parallelogram is equal to the sum of squares of its sides. So now here ABCD is a parallelogram in which AC and BD are diagonals such that which intersect each other at O. Now what is he asking to prove over here is the square of the diagonals is equal to sum of squares of the all the other sides. So therefore AB square plus BC square plus CD square plus DA square is equal to AC square plus BD square. These are the two diagonals. Since diagonals of a parallelogram bisect each other, we have that if this is a parallelogram over here, which we have drawn over there. So we have taken from top A, B, C, D. So A, B, C, D, and these are the diagonals which are there. So these two diagonals bisect at the point O. So BO is equal to DO are medians of triangle ABC and triangle ADC. You can see obviously over there respectively. So we know that the sum of the squares of any two sides is equal to twice the square of half of the third side together with twice the square of the median which bisects the third side. So now in triangle ABC, this is for the median, this happens, that is sum of squares of two sides is equal to twice the square of half of the third side. So here it is, you can see that sum of squares of any two sides you are taking here, OA is equal to OB, so therefore you are getting 2OB square plus 2 into, it is twice of half of the square of the third side. So which implies, take this as first equation, AB square plus BC square is equal to so much. Now in triangle ADC, OD is the median. You can see that triangle ADC, OD is the median. So how can we write? We can write this as sum of squares of the other two sides, that is AD square plus BCD square is equal to 2 into, it is twice the OD square plus twice the square of the third side, half the square of the third side. So twice this half the square of the third side is nothing but equal to 2 into half into AC whole square. So therefore now here you got first and second equation, AD square plus CD square is equal to 2OB square plus 2 into 1 by 2 AC whole square with the half 2 outside. So now adding 1 and 2, if you add these two, you are getting AB square plus BC square plus AD square plus CD square, which is equal to, so what are all on the right hand side, we are adding 2OD square plus 2OB square plus 2 into 1 by 2 AC whole square plus 2 into 1 by 2 AC whole square, which is equal to 2OB square plus 2OD square plus 2 into 1 by 4 AC square plus 2 into 1 by 4 AC square. So you are getting AC square by AC 2 plus AC square by 2 plus 2OB square plus 2OD square. So but OB is equal to OD. So you can write this as 4OB square plus AC square. But OB square is equal to half of BD. So therefore you can write this as OB is equal to OD is equal to half of BD. So therefore this, when you are writing AB square plus BC square plus CD square plus DA square is equal to 4 into 1 by 4 into BD square plus AC square, therefore which is equal to BD square plus AC square, hence proved. So now going into the seventh one, in the given figure, two chords AB and CD intersect each other at the point P. Prove that triangle APC is similar to triangle DPB, and we have to also prove that AP into PB is equal to CP into DP. So now in figure, two chords AB and CD intersect each other at the point P. So to prove that triangle APC is similar to triangle DPB, so what we have, second, AP into PB is equal to CP into DP. So what is the proof part? Triangle APC and triangle DPB, angle APC is equal to angle DPB because these are vertically opposite angles, and also we have that CAP is equal to angle BDP, angles in the same segment, you can see that. So therefore triangle APC is similar to triangle DPB using AA similar condition. Now next, again if we consider triangle APC and triangle is similar to triangle DPB, proof above in one we have, according to this proof we have this triangle APC similar to DPB. Now since these two triangles are similar, we can tell the sides are also proportional. So we are taking like this, AP by dP is equal to CP by BP. In this way you are taking. So therefore corresponding sides of two similar triangles are proportional. Therefore if you cross multiply, you are getting AP into BP is equal to CP into DP, which is the proof which we had to prove, hence proved. Now going into the eighth one. In the given figure, two chords AB and CD of a triangle intersect each other at a point P. So these two are the chords AB and CD. When they are extended, they intersect each other at a point P when produced outside the circle. We have to prove that triangle PAC is similar to triangle PDB, the smaller one and the bigger one. And we also have to prove that PA into PB is equal to PC into PD. Now in the given figure, two chords AB and CD of a circle intersect each other at the point P when produced out of the circle. So what we have to prove? That we have to prove that triangle PAC is similar to triangle PBD. This is PAC is this smaller triangle and PAD is the bigger, PDB is the bigger one. So therefore we also have to prove that PA into PB is equal to PC into PD. So we know that in a cyclic quadrilateral, the exterior angles is equal to the interior opposite angles. So now when you are taking this way, the figure, if we draw once again, these are the two chords which you are having. Okay, when they are extended in this way, they are meeting at a point. So you are having this as AP, AB, CD, A, B, C, D. This is point P. So now here you are having angle 1, angle 2. This is angle 1, angle 1, angle 2, angle 3, and angle 4. So this is 1, this is 2, this is 4, and this is 3. Okay, so now here we know that in a cyclic quadrilateral, the exterior angle is equal to the interior opposite angles. Therefore angle PAC is equal to angle PDB, and also we have that PCA is equal to PBD. So in view, that is angle PAC is nothing but angle 1 is equal to angle 2. From the figure you can see where is 2, and angle 3 is equal to angle 4. So now next, in view of this first and second, we have triangle. Because two angles are equal, therefore we can tell that triangle PAC is similar to triangle PDB. Now using AA similar condition, we can prove this next one. This first part we have proved, that is PAC is similar to PDB triangles, both are similar. Now we will consider the corresponding parts because these two triangles are similar. So we are taking PA by PD is equal to PC by this part we are taking PC by PB. Since corresponding sides of similar triangles are proportional, therefore which implies that according to the problem, whatever is given, we take the corresponding sides over there. So this is PA into PB is equal to PC into PD. Now going the ninth one. In the given figure, D is a point on the side BC of triangle ABC such that BD by CD is equal to AB by AC. Prove that AD is the bisector of BAC, angle BAC. So now in the given figure, D is a point on the side BC of triangle ABC such that BD by CD is equal to AB by AC. And we also have to prove that AD is the bisector of angle BAC, that is angle BAD is equal to angle CAD. So now from construction, what we are doing is, from BA we are produce the line to D such that AE is equal to AC. AE is equal to AC, and also join C to E. So now BD by CD is equal to AB by AC is given to us. Now we also know that BD by CD is equal to AB by AE, because AC is equal to AE. By construction you can see that AB is equal to AE. So therefore in triangle ABCE we have AD is parallel to CE. AD is parallel to CE. So by converse of basic proportionality theorem, angle 1 is equal to angle 3, that is corresponding angles. Angle 2 is equal to angle 4, alternate interior angles. Therefore AC is equal to AE by construction. Therefore angle 3 is equal to angle 4. So this is the third one. So angles opposite to equal angles of a triangle are equal, we know that. So using 1, 2 and 3 we get that angle BAD is equal to angle CAD. Hence AD is the bisector of angle BAC. Now 10th one. Nazima is fly fishing a stream. The tip of a fishing rod is 1.8 meters above the surface of the water and the fly at the end of the string rests on the water 3.6 meters away and 2.4 meters from a point directly under the tip of the rod. Assuming that her string from the tip of a rod to the fly is taut, how much string does she have out if she pulls in the string at the rate of 5 centimeters per second? What will be the horizontal distance of the fly from her after 12 seconds? Problem. Nazima is fishing a stream. The tip of a fishing rod is 1.8 meters above the surface of the water and the fly at the end of the string rests on the water 3.6 meters away and 2.4 meters from a point directly under the tip of the rod. Assuming that her string from the tip of a rod to the fly is taut, how much string does she have out if she pulls in the string at the rate of 5 centimeters per second? What will be the horizontal distance of the fly from her after 12 seconds? So now you can see that Nazima is sitting over here and she is fly fishing a stream and the tip of a fishing rod is 1.8 meters above the ground and she's at a horizontal distance of above the surface of the water and the fly at the end of the string rests on the water 3.6 meters away and 2 meters from a point directly under the tip of the rod. So it is here you can see from the tip of the rod, this is the tip of the rod, from here to this point it is 2.4 meters and the whole distance from where she is sitting and she is fly fishing is 2.4 plus 1.2 meters. You can see it is equal to 3.6 meters. So this from the figure you have this. So now what we are doing is we are just drawing one part of the figure, that is only from the rod where she has put it into the water. So ABC is a triangle. Consider AB is the height of the tip of the fishing rod from the surface of the water and BC is the horizontal distance of the fly from the tip of the fishing rod. So therefore AC is the length of the string. AC is the length of the string. Triangle ABC is a right angle triangle, we can see here obviously. So we can find out what is AC, that is how much of the string is out, the length of the string which is out. So therefore we have, using a Pythagoras theorem, AC square is equal to AB square plus BC square. AC square is equal to AB square plus BC square. So AC square is equal to 3.24 whole square plus 5.76 whole square, which implies that AC square is equal to 9 meters square, which implies AC is equal to 3 meters. So the length of the string out is 3 meters. Given that she pulls the string at the rate of 5 centimeters per second, therefore string pulled in 12 seconds is 12 into 5, which is equal to 60 centimeters, which is equal to 0.6 meters. So now here 0.6 meters, if it is pulled out, so the position of the string now it is at D. If you suppose that after pulling it out, string pulled in 12 seconds, let the position of the string be at point D. So now the fly is at the point D after 12 seconds. So therefore AD is equal to AC minus string pulled by Nazima in 12 seconds. That is 3 minus of 0.6, which is equal to 2.4 meters. So in triangle ADB, by Pythagoras theorem, we can see that AB square plus BD square is equal to, you can see from here, AD square is equal to AB square plus BD square. All of them are given. So we can see over here what is what. So therefore which is equal to 1.8 whole square plus BD square is equal to 2.4 whole square. So we have to find out what is BD from this. So BD is this part, we are finding it out now. So therefore, which is equal to BD square is equal to 2.4 whole square minus 1.8 whole square, which is equal to 2.52 whole square. So BD is equal to square root of this 2.52 is nothing but 1.59 meters. So horizontal distance of fly is equal to BD plus 1.2 meters, which is equal to 1.59 plus 1.2, which is equal to 2.79 meters.